Welcome to another video of thematic lectures. Today, I'm planning to do January 2023 WPH15 bar 01 Unit 5 paper discussion, thermodynamics, radiation, oscillation, and cosmology. So if you like my video, please subscribe my channel. You can share this video with your friends. There is no compulsion. That's completely up to your call. Anyway, this video should be useful for you. That's it. Anyway, we'll move to section A questions. So section A is from nuclear physics. A student used a detector and a counter to measure the background radiations. Background radiation count for 5 minutes. He used the value to calculate the background count rate. Which of the following would increase the accuracy of the student's value for background count rate? To increase the accuracy, always keep in your mind, if you want to increase the accuracy, we should increase the counting time. That is very important. By increasing the counting time, because while increasing the counting time, what happens? We will get a fair idea about the background count rate. So decreasing the counting time is not a right answer. So that is wrong. Then what about C? Repeat the count with a different detector and calculate a mean value. That will not make any sense. Whatever be the detector, the background radiation count, if you want to increase the counting rate, you should increase the time. Repeat the count in different location and calculate the mean value. That also not making any sense because that will decrease the accuracy. Then what about C? Repeat the count with a different detector. That will not change the accuracy. So which is the correct option? The correct option is B. Increase the counting time to 10 minutes. Hope you got it. Now a question related with the kinetic theory of gases. A cylinder contains a mixture of gas X and gas Y. The mean kinetic energy of the molecules of gas X is Ex, and the mean kinetic energy of molecule of gas Y is Ey. The molecule of gas X has twice the mass of molecules of gas Y. So here, the mass is different for gas X and gas Y. Which of the following equations is correct? Ex, the mean kinetic energy of X is equal to half Ey. Ex is equal to Ey. See, Ex is 2 Ey. Ex is equal to 4 Ey. So this is mean kinetic energy of molecule of gas, correct? So Boltzmann's law, the mean kinetic energy is equal to half K into T. So that means kinetic energy only varies with the temperature. Kinetic energy of gas molecules only varies with the temperature. Since there is no clue about a change in temperature, here only one thing is changing, that is its mass. Mass is independent because half kT, because half is a constant, K is Boltzmann constant, that's still constant. So kinetic energy is proportional to temperature. Since there is no clue about any temperature change, we can say the kinetic energy of molecule of gas X and kinetic energy of molecule of gas Y are exactly same. So the option for this is B. B is the correct answer. Clear? Okay, move to question number 3. The fusion of nuclei Fe56 in a star does not release energy. The fusion of nuclei of Fe56 in a star does not release energy. Which of the following is a reason for this? Which of the following is a reason why it is not releasing energy? We'll go through the options. The magnitude of nuclear binding energy is the least for 56 Fe. Magnitude of nuclear binding energy is greatest for Fe. So this B could be an answer, but B is not exactly the answer. I will explain why it is not an answer, because binding energy, if you are looking into the graph, so this is how the graph goes. That means, this is our mass number, and this is binding energy per nucleon, and maximum is for Fe56. So below this fusion occurs, and after this fission occurs. So why it is not releasing energy? What is the answer for this? Because binding energy per nucleon is maximum for Fe56. So which is the correct option? The magnitude of the binding energy per nucleon is greatest for Fe56. So option D is the correct. Okay, because if it is least, definitely fusion will occur. And if it is maximum, again, that means after this Fe56, still it's, mass number is great, highest, and still, the binding energy per nucleon is decreasing. Here, fission is happening. At maximum, that means the turning point is Fe56. So that is why it is not does not release energy. Fusion of Fe nucleon of Fe56 in a star does not release energy. So the magnitude of binding energy per nucleon is greatest for 56. So why B would not be an answer? Some students, okay, since they have that idea that binding energy is actually greatest for Fe56. But the thing is, you see the wordings. The magnitude of nuclear binding energy per nucleon is greatest. So this is just binding energy. So binding energy and binding energy per nucleon are different. So the option D is the correct answer. Now, question number 4. A student measured the temperature of 0.015 kilogram of wax as it cooled and changed the state from liquid to solid. Energy was transferred from the wax to the surrounding at the rate of 25 watt. The temperature of the wax varied with the time as shown. Which of the following expression gives a value of the specific latent heat of the wax? So the specific latent heat of the specific latent heat capacity of anything means it is actually the amount of heat required to change the phase. So here the liquid wax is now changing to solid wax. So we have an idea, that means while changing the phase, the temperature remains constant. So you just see the figure or see the graph, and where the temperature is remaining constant. That means here from the 50 to 150, the time, that means the time required is 50 to 150. So in this region, the temperature remains same. So here phase change is happening. So we know that the temperature is actually, without changing the temperature, the phase change is actually happening. So during this process, liquid is converting to solid. At that time, the heat is going out at the rate of 25 watts. So heat means it is actually energy. Energy per unit time is power. So 25 divided by time, the time taken for this process is 100 seconds, because it starts from 50 and it ends at 150. So difference between this is 100. So 25 by 100 is not 25 by 100, my bad. Like, we don't know the energy. So energy divided by 100 is the power. Power is 25. Therefore, the equation for energy is 25 multiplied by 100. That means 2500 joule. What is the equation for energy during the phase change? That is mass into latent heat. So that is 2500. Therefore, latent heat is equal to 2500 divided by mass. So which is the correct option for this 2500 means it is 25 into 100 divided by mass is 0.015. So which is the correct option for this? 25 into 100 divided by 0.015. So option A is the correct answer. Hope you got the idea. Now, question number 5. Absorption lines in the spectrum of light from a star are shifted to the absorption lines of the spectrum of light from a star are shifted to higher frequencies. So here a shift is happened. Okay. And this concept is known as, this apparent shift concept is known as the Doppler effect. So from star, a shift is happened to higher frequencies than the same lines viewed from the source of the earth. Which of the following can be concluded? So if frequency is shifted to higher part or higher range, if it is moved to the higher part of this absorption line, what happens is, the idea is very simple. That means because see the options, the star is accelerating away from the earth, the star is accelerating towards the earth, star is moving away from the earth. See, according to the concept of HR diagram and this Doppler effect concept that we learned in astronomy and astrophysics, there is no connection between the shift and the acceleration. So we can neglect the acceleration option A and B. So that means now the competition is between option C and D. So whether this star is moving away from the earth or star moving towards the earth. So if it is moving away from the earth, the apparent shift is to the lower frequency. And if it is moving towards the earth, means the frequency is higher according to the concept of Doppler effect. Because the compression is happening. The concept of compression is happening. So as a result, the frequency is high because the wavelength, the apparent wavelength is decreasing. That means high frequency is high. So which option is the correct answer for this? Option D. The star is moving towards the earth. Why it is not moving away from the earth? What is the reason? Because as frequency would be shifted to lower frequency for a star moving away from the earth. Because when it is moving away means its wavelength is expanding. Apparent wavelength increases. What happens if wavelength increases? Frequency decreases. It is inverse proportion. So which is the correct option here? That is option D. Question number 6. When a nucleus of americium emits an alpha particle, the energy released is 5.64 mega electron volt. Which of the following expression gives the decrease in mass in kilogram of the nucleus when it emits the alpha particle? So how will you answer this question? We know that concept of binding energy. The change in the mass multiplied by c square is the energy released, delta m c square. So therefore, if you want to find delta m, that is delta E by c square. And what is delta E? So this is in electron volt, mega electron volt. So we should convert this into joules. So 5.64 into mega means it is 10 to the power of 6. Into 1 electron volt, if you want to convert into joules, that is 1.6 into 10 raised to minus 19. That much joule divided by c square. What is the speed of light? 3 into 10 raised to 8 whole square. So if you are evaluating this, we will get 5.64 times 10 to the power of 6 and 10 to the power of minus 19. If you are multiplying 1.60 into 10 raised to minus 13 divided by 3 into 10 raised to 8 whole square. So which is the correct option for this? The correct option is A. Hope you got it. Now, a student investigated the absorption of gamma radiation by lead. With no absorber, the intensity of radiation was I0. When an observer of thickness 0.8 centimeter, the intensity was 0.25 I0. So that means the penetration power through lead. So when thickness increases, what happens? The radiation that is coming out, the intensity that loses. So when there is no absorber, the intensity of a gamma that is measured on gamma, so that is measured on GM2, that is I0. When with an absorber of thickness 0.8 centimeter, that is 0.25 I0. So that means from this, we got an idea that intensity and thickness are inversely proportional. So when thickness increases, the intensity decreases. So intensity is proportional to 1 over thickness. So here, intensity is equal to constant by thickness. So you can use an idea here. That means when absorber is 0.8 centimeter thickness, the intensity is 0.25. So 0.25 I0 is equal to K by 0.8 centimeter. Now, the thickness we required when intensity is 0.5 I0. So 0.5 I0 is equal to K by T. So then this is equation number 1 and this is equation number 2. So you try to divide these two equations. Equation 2 by equation 1. What happens? 0.5 I0 divided by 0.25 I0 is equal to K over T divided by K by 0.8. By 0, I0 got cancelled. 0.5 divided by 0.25, that is 2. And K got cancelled. So what happens is 2 is equal to 0.8 by T. So that implies as T is equal to 0.8 by 2. That is 0.4 centimeter. So which option is the correct one? B, 0.4 centimeter. Hope you got the idea. Question number 8. The Hertzsprung-Russell diagram or HR diagram. W, X, Y, and Z below show a star cluster at various times when the star cluster is at different stages of evolution. Which of the diagram represents the cluster in the final stage of evolution? So to get an idea about this question, you can just go through the HR diagram concept. So this snip I have taken from our textbook. So you can see this. This is our main sequence line. So if you go through the life cycle of low mass star and the massive star, so it starts from protostar, then it becomes sunlight star, red giant, then planetary nebula, and finally, the final phase is white dwarf. So see the figure. So it starts from nebula, protostar, main sequence, then it's red giant, and finally, this is in the final phase, there is no red giant, only white dwarf. So see the figure. See option, the option A, W means, what is the meaning of W? In this diagram, there is white dwarf starts and red giants in the cluster. So that means white dwarf and red giants are there. So in the final stage, yes, white dwarf is there. So there is a chance for option A, correct answer. Anyway, option B is wrong because X, there is red giants and no white dwarfs. So if no white dwarf, that is not the final evolution, final stage. So this is not option. B is wrong. Then what about Why? As there are white dwarf stars but no red giants in the cluster. Then that means there is a chance for option C as well. We will see which one is correct. What about D? All the stars in the cluster and the main sequence. That is not possible because after the main sequence, white dwarf should be there. So this is not a correct answer. So now the competition is between A and C. So which one is the correct answer? Option C is the correct answer. Why? So we can see that there is no red giant in the final stage. Only the white dwarf is present. So which one is the correct answer? The option C is the correct answer. This is also not correct. So the option C is the correct answer for this. Hope you got it. Move to question number 9. An object oscillates with a simple harmonic motion. The period of oscillation is 0.65 seconds and the amplitude is 0.12 meter. Which of the following expression gives the maximum velocity of the object? For any simple harmonic motion, the maximum velocity could be explained as x0 times omega. What is x0? That is the amplitude. X0 is amplitude. And omega means, since the time period is given, what is the relationship between angular frequency and time period? 2 pi by time period is omega. Therefore, maximum velocity is 0.12 multiplied by 2 pi divided by 0.65. So which is the correct option for this? The correct option for this is option B. So that is the idea about question number 9. Hope you got it. Okay, now question number 10. So in question number 10, the graph shows an acceleration with a time for a particle undergoing simple harmonic motion. Which of the following graph shows the velocity v varies with the t over the same time interval? So what is the relationship between acceleration and velocity? If we are differentiating velocity with respect to time, we will get acceleration. What that means? It means that the slope or the gradient of velocity is acceleration. So you can see that this acceleration is starting from 0 and this is increasing. So that means it starts from 0 and the gradient is increasing and it reaches to a maximum point, and then after that the gradient is decreasing and it reaches to 0, keep on decreasing, and it reaches to a minimum value, then again increasing. So you just evaluate this concept. See, at this point velocity itself 0. So to get a gradient 0, that should be a maximum point or minimum point. That should be a maximum point or minimum point. So obviously in this option A, this point is not a maximum or minimum. That means it is not a turning point. So we can just neglect option A. Then what about option B? Option B could be an answer. Why? Because the velocity starts with a minimum value. So if you are taking the gradient, see, if you are drawing a tangent, see, the tangent is passing parallel to time axis. So this is at this point the acceleration is 0. And if you are finding the gradient is keep on increasing. So this could be an answer. Then we will see whether any other options satisfies this condition or not. Anyway, this is also not possible because it starts from 0. So that is not possible. Then what about this option D? Yes, it starts from the maximum point. So if I'm drawing a tangent, yes, acceleration is 0. But if you are finding the next level, next values, like, if you are drawing the tangent, you can see the tangents are actually going down. So that means the gradient is giving negative. So that is not the correct answer, because gradient should be positive because the acceleration is going upwards, right? So which one is the correct option for this? The answer for this question is therefore B. B is the correct answer. Hope you got that idea. So that's all about section A questions. In the next video, I will explain the section B questions. Thank you very much.